Welcome back to ClearSpot. You've probably heard the term AI agents thrown around lately. Maybe you've also heard automation. And here's the thing, a lot of people use these words interchangeably like they're the same thing. They're not even close. And if you're managing a solar farm or running any kind of infrastructure operation, this difference could literally cost you tens of thousands of dollars. So in this video, I'm going to show you exactly what AI agents are, how they differ from traditional automation, and most importantly, why your solar farm probably needs one but doesn't even know it yet. Let's break it down. Let's start with automation, because that's what most people think of when they hear intelligent systems. Automation is actually pretty simple. It's a predefined set of rules that trigger actions. Here's how it works. Something happens. A sensor detects it. You've programmed a rule. The rule says, if X happens, do Y. So the system does Y every single time, reliably, predictably. Think of it like a thermostat in your home. The rule is, if temperature drops below 20 degrees Celsius, turn on the heater. If temperature rises above 22 degrees, turn off the heater. That's automation, simple, binary. It either triggers or it doesn't. Now, in solar, automation looks like this. A string-level monitor detects that one string has dropped to 50% of normal output. Your automation rule says, if output drops below 60%, send an alert to the technician. The system sends the alert. Every time. Without thinking. Without context. That's useful, right? Absolutely. Technicians know something's wrong. But here's where automation breaks down. Problem number one. It only follows the rules you programmed. If you didn't think to program a rule for that specific scenario, the system does nothing. It sees the problem coming, but because there's no rule for it, it stays silent. Problem number two. It can't adapt. What if today the string dropped because of soiling, but tomorrow it dropped because of a bypass diode failure? Same problem, same drop to 50% output, but completely different solutions. Automation will trigger the same response both times, even though they need different fixes. Problem number three. It's reactive, not predictive. Automation detects problems after they happen. A technician gets an alert about the string that's already failing. By then, you've lost generation for hours. So automation is powerful. It's reliable. It's been running industrial systems for decades. But it has a ceiling. And that ceiling is, it can only do what you've explicitly told it to do, exactly when you told it to do it. Now let's talk about AI agents. And this is where things get interesting. An AI agent is fundamentally different from automation. Here's why. An AI agent is an autonomous system that can perceive its environment, analyze what's happening, make decisions, and take actions. All without being explicitly programmed for every scenario. Let me break those down. Perceive, the agent ingests data from multiple sources, not just one string monitor. Real-time SCADA data, weather sensors, inverter communications, historical performance records, maybe drone inspection imagery. It builds a comprehensive picture of what's actually happening on the site. Analyze, the agent doesn't just check if a single value is above or below a threshold. It analyzes patterns. It recognizes that today's 50% drop on string A, combined with a 40% drop on string B, plus a dust storm warning from the weather service, plus the fact that cleaning was scheduled for 2 days from now, all of that together points to soiling, not a hardware failure. Okay, so here's the key part. The agent doesn't just execute a pre-programmed response. Instead, it evaluates multiple potential actions, predicts the outcome of each one, and, chooses the best course of action given the current circumstances. In this case, it figures out, a dust storm is coming in 6 hours. Cleaning the panels now will take 2 hours. Revenue loss from dust will exceed cleaning costs by 3 times. So, the decision? Schedule emergency cleaning now. Then, the agent triggers the optimal action. It sends an alert to the cleaning crew with priority status, updates the work order, and adjusts the forecast models. Notice what just happened. The agent made a decision that a human operator would have made, but it made it in, like milliseconds, with perfect data, no emotion, and no bias. Now here's where it gets even more interesting. The agent tracks outcomes. It learns. 3 weeks later, another dust storm warning comes in, but this time, the agent has learned from the last time. It knows exactly how much soiling to expect. It knows the cleaning crew's schedule better. It predicts with even higher accuracy whether cleaning now is the right call. The agent actually got smarter. Automation can't do that, but there's more. Agents can coordinate with other agents. So, Imagine you have a maintenance agent that predicts when components will fail, a performance agent that optimizes output, a safety agent that ensures nothing dangerous happens, and a grid response agent that knows when the grid is going to ask for curtailment. These agents can talk to each other. For example, the maintenance agent tells the performance agent, the cooling system is degrading. We're going to need to reduce stress on the inverter next month. The performance agent then adjusts its optimization strategy accordingly. What you have now is an ecosystem of autonomous systems that coordinate without human oversight. That's agentic orchestration, and honestly, it's the future of how complex systems will be managed. Okay, let me show you a side-by-side comparison so you can see exactly where they diverge. When it comes to the scope of decision-making, automation is all about if X, then Y. It's just simple if-then logic. But AI agents, well, they consider multiple variables, historical, context, predicted outcomes, and trade-offs. Now let's talk about adaptability. Automation follows the same rules every time, same input, same output. On the other hand, AI agents actually learn and improve. So, the same input today might give you a different, better output tomorrow, based on what it learned. Moving on to speed of response. Automation is fast, following pre-programmed rules instantly, but AI agents are even faster. They analyze complex scenarios and make optimal decisions in like milliseconds. What about handling unexpected situations? Automation gets stuck. If the scenario wasn't in the rulebook, it just doesn't know what to do. AI agents, though, figure it out. They use pattern recognition and reasoning to handle novel situations. Now, for cost optimization. Automation executes the same action every time, regardless of cost. But AI agents actually evaluate the financial impact of each decision and choose the most cost-effective path. Scalability is another big one. With automation, adding new rules means reprogramming, and honestly, it doesn't scale elegantly. But AI agents, they get smarter the more data they see, so they scale naturally. So, do you see the pattern? Automation is rigid. Agents are fluid. Let me give you a concrete example so you see this in action. It's 6 a.m. on a Tuesday, a 10-megawatt solar farm with 30,000 panels. Overnight, a dust storm hit. Dust accumulated on about 60% of the array. Output is going to be degraded today. Now let's look at scenario 1. What traditional automation does. At 6:15 a.m., a monitor detects soiling detected. The automation rule fires. Send alert to operations team. Alert sent. Operations team sees it at 6:45 when the bye-bye. They look at the forecast. Dust storm passed. Sky is clearing. They make a decision. Should we clean now or wait for the weekly scheduled cleaning tomorrow? They don't have perfect data. They guess. Let's say they decide, wait. We'll clean tomorrow. Result. Farm operates at 30% capacity all day. 1 day of lost revenue. Now, scenario 2. What an AI agent does. At 6:01 a.m., before the operations team even wakes up, the agent has already analyzed current dust levels from satellite imagery, if available, or calculated from performance metrics. It checked the forecast, clearing by 9 a.m., but another dust storm possible Thursday. Reviewed cleaning crew schedules. Analyzed revenue impact. Cleaning today costs $800, takes 2 hours, loses 4 megawatt-hours generation versus waiting, which loses 8 megawatt-hours generation, worth $3,200. Predicted that this dust will clear faster than the last storm due to wind patterns. Decision. Clean at 8 a.m. before peak generation hours. Minimize revenue loss. Prevent Thursday's dust from accumulating on already dirty panels. Result. Farm cleaned at optimal time. Lost revenue. $200 instead of $1,000. That $800 difference? That scales. Across a portfolio of 50 sites, that's potentially $40,000 in recovered revenue per storm event. And that's just one scenario. Multiply that across a year of operational decisions. Maintenance scheduling, grid curtailment responses, technician dispatch optimization, equipment failure prediction, and you're talking about a 5 to 15% improvement in overall asset performance. That's the difference between automation and agents. So here's the question. Why is this becoming critical for solar right now? 3 reasons. Reason 1. Scale. 10 years ago, most solar farms were relatively simple. A few megawatts, centralized, easy to manage with basic automation. Today, distributed PV systems, utility-scale farms, portfolios spanning multiple geographies, tens of thousands of data points every minute. No human can process that complexity. Automation breaks down at scale. Agents thrive on it. Reason 2. Grid integration. The grid is changing. It's asking solar farms to do things that require real-time intelligence. Curtailment response, frequency support, reactive power management. Automation can follow a curtailment command, but an agent can optimize response in real time, weighing revenue impact, battery state of charge, weather forecasts. Reason 3. Competition. Asset owners are racing to squeeze every fraction of a percent of efficiency from their solar farms. The operators using agents will outperform those using automation. It's not a question of if agents become standard, it's when. The time to start thinking about agentic systems isn't when you're forced to. It's now, when you can be ahead of the curve. So to recap, automation follows rules. AI agents make decisions. Automation is reactive. AI agents are predictive. Automation is rigid. AI agents learn and adapt. For solar, automation got us to where we are, but agents are going to take us where we need to go. In the next video in this series, we're going to dive deeper into how to actually build an agentic system for a solar farm. What data you need, what architecture looks like, how to start implementing this. Like, share, and subscribe for more solar insights. ClearSpot. Smart device, smarter decisions.